My name is Adrienne Mallory, and I am the chair and instructor of the Engineering Graphics program. Engineering graphics was formerly known as drafting and design and drafting technology, but it's so much more than that now, where everything was done once upon a time with pen and paper on draft boards is now almost 100% digital, which is great because with the advancement in technology, it really allows us the opportunity to take anything that we can think of from concept to creation. We just are the land of inventions with floor plans and 3D printing and blueprint design and really anything imaginable. We are what I like to call the graphic designers of the engineering world, where we work very closely with architects and engineers to bring the things that they are creating to life. I am so thrilled that I am able to offer my students the opportunity to work with 3D metal. For so long, we have worked with different types of plastic composites, so when we're working with this metal, it really gives us an opportunity to get that real life feel for a product that we've created to make sure it works the way that we had hoped it to work and the way that it was designed to work. So we're working with one of the first systems of its kind, the desktop metal 3D printing system. And it's a three-step system where students will create their part in some type of CAD software, be it Inventor or SolidWorks, or even Tinkercad for on our junior levels. We can take it from there to put it into the printer, where it'll use a stainless steel composite to print out the part. From there, that composite is put into what's called a debinder. That's the second step of the system. The debinder just takes that part and cleans it up a little bit. You know, it'll come out just a little rough, but the debinder cleans it up and prepare it for the third system, which is the sintering process. The sintering process is basically a furnace where you will put the part into something of like a Dutch oven, and then it'll cook. It'll heat up to roughly 1500 degrees to make sure that that stainless steel composite that we started with will solidify and harden up into a metal part. Now, the process does take longer than typical 3D printing for rapid prototyping. This is not a rapid process, but it really gives us the real world feel for the part that we've created in our minds. We know we want it to work a certain way, and the metal printer just really gives us the opportunity to make sure that we're doing it right. So what we do here in the lab is just on a prototype basis, but in industry, this is something that they use to create real parts. What we have here may not be on the same grade as far as the expense of the material and how hard it could get, but the process is still the same. You still take it from concept to creation with a sketch, with the idea that's then created and brought to life.